Welcome back. First day of stats for 2024. Here we go. So this is section 1-1. Really, all of chapter 1 is just kind of like basics, definitions, things that you might need to know, basic building block stuff of just like kind of setting the stage for everything that we will do this semester. Right? Just so you guys know, we will have an assessment every chapter. Whether that chapter is 3 sections, 2 sections, 5 sections, 6 sections, whatever. Every chapter that we will have an assessment over it. And each chapter assessment, I will call a test. Each chapter test, each chapter will have its own test, even if the chapter is only 2 sections long. There are some of them that are only 2 sections long. I think chapter 10 is only 2 sections long. Chapter 9 is only 2 sections long. So we will have a chapter test for each one. Those will go in the test category of the CCP grading scale. We will have some quizzes throughout. Like I think it's chapter 2 that has 5 sections, or maybe it's chapter 3 that has 5 sections. We'll do after like 3 or so sections. We'll review and then quiz, and then we'll take our test once we get time to it. But chapter 1 is just 3 sections. We'll do section 1-1 today, section 1-2 on Monday, section 1-3 on Wednesday, and then we'll review tests by next Friday over chapter 1. It moves pretty quickly as we go through, because we have to get through 9 chapters in the semester. So we'll do roughly like 4 chapters per 9 weeks. So we get going pretty quickly. But again, it's not too bad. So again, chapter 1 is just basic stuff. Like how do we define statistics? How do we define data? Well, the book's formal definition of data is that data consists of information coming from observations, counts, measurements, or responses. However you want to collect that data. But data in itself is just, by definition, information that comes from observations, counts, measurements, responses. Data could be numerical. Data could be what we would call qualitative data. We'll talk about what that means pretty soon here. We've got quantitative data, which is numbers. Qualitative data, which is actual things. Like if I asked you all what your favorite movie was, that's still data, right? I'm still getting responses, right? If I counted the certain amount of times you did something in a class, that would be data. Some observations, just like what you are doing, things that I see, that's data. Anything like that, anything that you observe, count, measure, or get responses from, that's all considered data. And so statistics is the science of collecting, organizing, analyzing, and interpreting that data in order to make decisions. And that last part is the really important piece. In order to make decisions. By the end of this class, we will get to this thing called hypothesis testing, where we will make decisions upon the data that we have. Statistical decisions, the ones that we say, okay, if we know this, then we can say something else with a certain level of certainty, right? If we have seen these things happening in the past, then I can predict what's going to happen in the future with a certain amount of confidence, right? And that's what statistics is all about. Man, you are so valuable to any sort of place of business if you can predict the future, right? If you can look at what's happening in the past and say, I believe since that has happened in the past, that this is going to happen in the future with some sort of certainty, man, you are a valuable employee, right? So I think statistics, that's why statistics is required for, man, I don't know of a major that my friends had in college that like did not require at least one level of statistics. Even my friend, she was going into like what was her major? It was like she wanted to be in charge of like a nursing home. Like that's what her end goal was. So she said that's what she wanted to be. It was like some sort of like business degree, but had a care component to it. I don't even know. Shout out Megan if you're watching on YouTube. She even had to I had to I helped her through her statistics class. But it was like a business statistics class. But a lot of it it's the same type of material. Okay. All right. Some other definitions that we have. When I talk about a population, a population is the collection of all the outcomes, responses, measurements, everything that you could possibly observe, everything that you could possibly count, everything that you could possibly, compile. That's the population. Everything, right? Leaving nothing out, right? So if I had said, I want the population of the seniors of Lake High School, I would want to get every single senior, not leaving a single one out, right? If I said I wanted the population of the teachers of Lake High School, I would need every single teacher, right? Not just a sample of them, a whole population. A sample is something different. A sample is a subset of the population, okay? And it has to be a subset. You can't. If I took a sample and I said, okay, I'm going to run a survey. I'm going to take a sample and I'm going to collect some data. And I was going to get a sample of seniors of Lake High School, and then I accidentally had a junior. That is not technically a subset, right? Because there is an element within that set that's not in the population. So therefore, it's not a subset. It has to be a subset. Must be a subset. Okay. A population, again, is everything. And that population doesn't necessarily, a lot of times we think and we describe population as like people. That's not necessarily always the case. Like if I had said, what is the population of classes that you could take at Lake High School? Well, that would be like the whole course book, right? That's all the possible outcomes that you could pick. So if I picked a class at random, I would say the entire class, all the classes would be my all possible outcomes, right? All of them, right? If I had said, pick a color of the rainbow, okay, all the colors of the rainbow would be the population, right? So population and sample. Sample is the subset. Population is the big amount. Okay, 200 registered voters were polled, and 56% of them expected to vote in the upcoming election. What is the population? What is the population here? Now, when I say to identify the population, please be specific. Okay, be as specific as possible without narrowing your focus too much to call it a sample. Because when I say identify the population, sometimes people say, "Oh, okay, it's all voters." Yeah, not really, because the way this is worded, right? Or maybe it's all people. No, the population is not all people. Look at the way it's worded. 200 registered voters. Okay, registered voters. So all registered voters. Voters. Okay. That's everybody in this. Okay, so be as specific as possible when you're talking about the population. But you want to say that it's all of that thing. All registered voters. Right? All registered voters. Were polled, and 56% of them expected to vote in the upcoming election. Okay, so the sample is my 200 registered voters. That's the subset of all registered voters, right? It is the sample. It is the subset. Those 200 come from all the registered voters. That sample comes from the population. And 56% of them expected to vote in the upcoming election. Describe the sample data. This is kind of like your homework problems. That's why I'm formatting it in this way. So the sample data is basically saying, well, out of those 200, 56% of them expected to vote, right? Expected to actually cast their vote. So 56% of 200 expected to vote. Okay. And we could actually find out what that 56% is, 0.56 of 200. And that would be roughly, 112. There's 112 people out of those 200 that are expected to vote, right? So identifying the population, identifying the sample, and then describing out of that statement, what is the sample data? What are you really talking about in terms of the sample? What's being described to you? Okay, so you'll have a couple homework problems like that. And then we have this idea of having a parameter and having a statistic. Having a parameter and having a statistic. A parameter is a numerical description of a population characteristic. Okay, so it's a number. It's a numerical description. There are different types of parameters. Like if I had said, what is the average GPA of all Lake High School students? Well, the population is all Lake High School students. So therefore, my average is my parameter, right? My average is my parameter. We'll call that mu a little bit later on. My average, my population mean, my population average is my parameter. And it's a parameter because I'm talking about the entire population. Everybody's GPA all averaged together. That is the parameter. Now, if I had said, okay, if the population is all students at Lake High School, and then I took just the seniors, and I said, okay, a subset of that population, just the seniors, population being all students of Lake High School, per sample is just the seniors of Lake High School, and I said, okay, let's calculate that sample GPA. Okay, now that's a statistic. Okay, that statistic is a numerical description of a sample characteristic. So if I sample out of the entire population and talk about something numerical about that sample, we would call it a statistic rather than a parameter. Now I'm talking about it in terms of mean. I'm talking about it in terms of average, but I could use any sort of descriptive statistic. Like I could talk about the mean, the median, the mode, the range, the standard deviation, the variation, any sort of piece of data that I have that talks about the entire population would be considered a parameter. Any piece of data that I would use to talk about a sample would be called a statistic. So parameter is, I say the P's go with the P's. The parameter goes with population, the S's go with the S's. Statistic goes with sample. Okay. Population goes with parameter, statistic goes with sample. Okay, so sample or parameter. I really think this should say statistic or parameter. I don't know. A survey of several hundred collegiate student athletes in the United States found that during the season of their sport, the average time spent on athletics by student athletes is 50 hours per week. Just as a side note here, I get all these examples from the book, and if you really go into the book and look at each example, it gives, like, it cites its source for every single piece of information that it gives, which is really good. I mean, that's a great thing to have. I mean, it's got to be so tedious for the people that wrote this book. But just know that every piece of information they give in the book was accurate at the time of publishing, and it's all like backed up by a specific study. So, like for example, there was a survey of several hundred collegiate student athletes in the U.S. that found that during the season of their sport, the average time spent on athletics by student athletes is 50 hours per week. I would not be surprised at that. Man, think about that. So if you're a student athlete, like you go to college, you're doing your sport at your university or your college, whatever. You spend 50 hours per week on that sport. That's more than a full-time job just doing the sport. Not academics, athletics, just straight up athletics. I mean, granted, if you're a collegiate student athlete, you're probably on scholarship, so maybe that's your full-time job. But man, that's a lot. 50 hours per week. Okay, so is that a parameter or a statistic? Is that 50 hours per week a parameter or a statistic? Well, am I talking about a sample or am I talking about the entire population? Sample, so it would be statistic, right? A survey of several hundred collegiate student athletes, right there. A survey of several hundred collegiate student athletes, right there. So therefore, we can talk about it as a statistic rather than a parameter. Side note, what's the population then? If that is a sample, a survey of several hundred collegiate student athletes, what is my population?
All the student athletes in the United States?
Yeah. All collegiate student athletes in the U.S. Yeah, exactly. All of them. So just a sample of them would be a statistic that's 50 hours per week. Now, the freshman class at a university has an average SAT math score of 514. Can't read. The freshman class at a university has an average SAT math score of 514. Parameter or statistic? Parameter. I mean, we're not given a lot of information here, but I believe that they are saying that the population that they are looking at is the freshman class. Right? By the wording of this, it's the freshman class at that particular university. Right? So we would call that a parameter. Now, if we had more information, if we had then been told, that freshman class was in a study about, I took the freshman class at Akron and was looking at freshman SAT math scores of all MAC schools, Mid-American Conference schools, right? So in that case, then it would turn into a statistic. I didn't change the number, but I changed what we were looking at, and we could turn it into a parameter versus statistic. You see what I mean there? So it really depends on the wording of the problem. I try to be as specific as I can, especially on the quiz and test questions, so you know exactly what's going on. Now, the reason why this is so important to define whether something is a statistic or a parameter is because, in that formula sheet, so much depends on whether you were talking about a population or whether you're talking about a sample. The equation, the formula that you use usually depends on, okay, am I talking about a sample or am I talking about a population? If I talk about a sample, I got to use this formula. If I talk about a population, I got to use a completely different formula. Not completely different, but a different formula. So it just depends, and that's why we spend so much time talking about what is it and how do we define it. Okay, now the title of chapter 2 is called Descriptive Statistics. Okay, all of chapter 2 will be about descriptive statistics. So what is descriptive statistics? Well, descriptive statistics is the branch of statistics that involves organization, summarization, and display of that data. Okay, so if I say to you, I have gathered all the GPAs of freshmen, then I could make a pie chart of that GPA. I could make a bar graph of those GPAs. I could make a stem and leaf plot of those, just showing what it looks like. I'm not making any decisions about it. I am not saying anything about it. I'm not trying to make an opinion about it. I'm not trying to demonstrate if it's good or bad. I am just showing you what it is. And if I'm just showing you what it is, that's what's called descriptive statistics. I like descriptive statistics better than inferential, and we haven't talked about what it is, but inferential statistics, because descriptive statistics kind of like takes opinion out of it. It takes emotion out of it. It takes all choices out of it. Descriptive statistics just says, here's the data. Make your decisions on your own. Do whatever you want with it. Here is the data. Let me present the data to you in a given manner. That is descriptive statistics. It involves organization, summarization. You can summarize your findings, right? Not saying, not trying to sway an opinion, not trying to make a decision about it. I'm just summarizing my findings and then displaying my data, just showing you what I have, not making any decisions about it. Find which parts of are the descriptive statistics in the following statement. A large sample of men aged 48 was studied for 18 years. For unmarried men, approximately 70% were alive at age 65. For married men, 90% were alive at age 65. Okay, so if I'm talking about the descriptive piece of this, this is a summarization of findings, right? I'm not showing you all the data here, but I'm just kind of summarizing what we have found. Well, after 18 years, unmarried men were approximately 70% were alive at age 65, but married men, 90% were alive at age 65. Okay, so the descriptive piece about this is that unmarried, from my eye, unmarried, 70% alive at 65. Married, 90% alive at 65, right? That's the descriptive piece about this. Now, could you make a decision about that? Could you make an opinion about that? Yeah, but that's on you. Did I make that statement? No, I didn't say that statement. All I said was, here's what we found. Okay? If you make an opinion about it, if you make a statement about it, if you make a conclusion about it, well, that's what it turns into inferential statistics. Okay? Inferential statistics. The key word there, the root word there being infer, being to able to make decisions about it, right? Inferential statistics is the branch of statistics that involves using a sample to draw conclusions about a population. That's pretty much, okay, once we get past chapter 3, and actually, no, really kind of chapter 2, the rest of this class is all inferential statistics. Getting an idea of, okay, if I see, like, for example, if I took this classroom's GPA, how confident would I be to say, well, your GPA would match the entire population of schools GPA, right? how confident would I be in that statement, right? Or maybe I said this: I take this class's GPA, I average it together, and then I said I'm going to make a decision about the entire population of all students in America GPA, right? Because would it be difficult to find every student in America's GPA? Yeah, it'd be super difficult, right? It'd be very, very difficult. So what we can do here is take a sample and then with some sort of certainty, with some sort of confidence, say that based on this sample, that I can make a decision about the entire population, about everybody, right? Now, would that truly be the case? Well, the best case is if the sample is random, right? Was this sample random? No way. I'm just talking to you guys and I poll you guys, right? That's not good, right? The population, the sample that I take would need to be random, right? It need to be a random sample. So that would not be the best case. And that's why you always have to look at if you look at a statistic, if you read a statistic, if you come across some sort of piece of data, some information, it's always good to get it from a reputable source, because how do you know that they didn't just ask the people that they wanted to ask, right? You got to be very careful, especially, as you guys are growing older. A lot of you are probably going to, could you vote in the next election, you guys? Whoa, that's so cool. So like I bring up elections because there's all sorts of statistics people throwing around, right? You can spin anything the way that you want it to. But people throw around all sort of information, all sorts of numbers, and never give any reasons to back it up, and never give any actual true data to support what they believe. But there are times when you read an article and you read if you're looking at a newspaper, if you're looking at an article, and they back up their data with true information, with actual true surveys, right? Actual true polls, right? And those polls are from reputable sources, and those polls are from places that do randomly sample and don't just sample the people that they want to sample. I fear sometimes where certain media outlets will only sample the certain people that they want to sample to get the data that they want to get. Republican, Democrat, whoever, right? They only survey their only particular people and say 90% of people want this person elected, right? Well, how did you actually survey that? Well, I only picked the people that I wanted to pick. Well, that's not great, right? So inferential statistics is the way that you can put spin on it, right? The way that you can say, okay, given this about a specific statistic, can we say something about the entire population? There's all these things, called exit polls, right? Basically, poll workers are sitting at the exit of polls and actual voting polls on voting day, and they're asking people as they come out, who did you vote for? Those are exit polls, right? And then they can say, okay, based on exit polls, we believe that this is going to happen in the state, right? So you're getting people who actually voted, but maybe you're only standing in a specific spot. Maybe you're not all over the place, because a polling location down in the middle of Canton is going to be very different from a polling location here in Uniontown, right? They're different populations, they're different people here, so they're going to be voting different ways. So you have to be very careful about where you do those things. But if you do that in the right way, you can get an idea of how the entire state is going to vote. We had a sample, we looked at that sample, and we determined something about the entire population. That's inferential statistics. That's making a decision about a population based on a sample that you took. And the last example, guessing that being married is associated with longer life, would be then taking inferential statistics, right? We said that unmarried men were 75% of them were alive at 65. Married were 90% alive at 65. So therefore, we could say that, then being married would make you live longer, right? That is inferential statistics. That's what, taking that decision upon that's inferential statistics. Here we go. A survey conducted among 105 boys and girls at Lake High School showed that 76% of the boys like math class, while only 40% of the girls like math class. This was not in the book. I just kind of threw this together. I don't back up my statistics with real actual examples. So A survey conducted among 105 boys and girls at Lake High School showed that 76% of the boys like math class, while only 48% of the girls like math class. Identify the descriptive aspect of the statistic. Okay, 76% of boys liked math, 48% of girls liked math. Okay, am I saying anything about like, oh, more boys like math than girls? No. That's just bare bones. That's just showing you what I found, right? It's just saying, here's the evidence. Here's what I have. Take it, do with it what you want. That is descriptive aspects. Inferences that you could be drawn from this survey. Okay, well, okay, so then you could make a statement, well, more boys like math than girls. Now, here's why I don't like inferential statistics very much. Are we told anything about the ways that I conducted my survey? Am I told about how I conducted my survey, or the sample that I chose, or how I chose that sample? No, we're not told anything about that, right? We're not told anything about that. So my findings could be swayed in any sort of way, right? Maybe my sample wasn't random. Maybe I was only asking particular boys, maybe I only asked boys from honors classes, and I only asked girls from classes that didn't really do good math, right? Okay, in that case, well then I'm getting girls that don't like math, and then boys that do like math. If I had surveyed those same girls from honors classes, well then that percentage is probably a little bit higher, right? Because they're better at math, they probably like math a little bit more, right? So I'm not told anything about my survey. We don't know what's going on behind the scenes, right? And then our next couple sections is going to be about, well, how do we collect that data in the correct way? What's the best way to collect that data? What's the best way to say, okay, how do I make my sample random? How do I choose those people? Okay. All right, that is it for lesson 1-1. Here is the assignment. You can use the rest of the time to do those 4 problems. We got 4 problems. That's it. Okay, let me turn off my video. I'll leave that up there.